Morning students. Now I would like to explain the structure and working of a Gunn diode. So Gunn diode is basically a diode made up of N-type semiconductor. It does not possess any PN junction. So when N-type layer, moderately doped N-type layer is sandwiched between the two heavily doped N-type semiconductors, then the Gunn diode will be formed. Two metallic contacts, namely anode and cathode. So generally here gold metal is used. So anode is connected to the positive terminal of the battery and cathode is connected to the negative terminal of the battery. Anode is connected to the positive terminal and cathode is connected to the negative terminal of the battery. It is the forward biased section of Gunn diode. So it is also called transfer electron device. That means in this case there is no P type semiconductor. Because of electron transfers, entire operation takes place. The main advantage of Gunn diode is it exhibits negative resistance characteristics. So generally Gunn diode is made up of gallium arsenide and indium phosphide materials. These materials exhibits different properties. In semiconductor there is a valence band and there is a conduction band. So the gap between the valence band and conduction band is called forbidden gap. If energy is applied, some of the electrons in the valence band is liberated from valence band into the conduction band. As a result, a vacancy is created. That vacancy is nothing but a hole. And conduction band electrons are called free electrons. These free electrons plays important role for constitute current. So again energy is applied in materials like gallium arsenide, indium phosphide. These electrons are moved into the upper valley. So this upper valley is filled up with number of electrons by applying 0.36 electron volts. As a result, density of the electron is increases and mobility is decreases. Simply this is what we call Gunn effect. So this is invented by J.B. Gunn in 1961. It is supported by RWH theory in 1963. So here the Gunn diode characteristics. So Gunn diode characteristics, V is taking on x-axis, I is taking on y-axis. So Gunn diode, basically this blue region indicates, simply it is called the ohmic region. That means in this ohmic region V is directly proportional to I. When voltage is applied, some of the electrons from valence band is liberated into the conduction band. As a result, some amount of current flows in this region. So here V is directly proportional to I. Once it reaches the peak point, so by applying additional energy, what happens simply, these electrons in the conduction band is entered into the upper valley. So as a result, what happens simply, the density of the electron is increases. So obviously mobility of the electrons is decreases. As a result, voltage is increases in this direction, but current is decreases. So this region is called the negative resistance region. After some time, these electrons from upper valley is entered into the conduction band and Gunn diode behaves like a normal ordinary diode. So this portion is very important. Because of negative resistance, Gunn diode acted as a microwave oscillator. So entire operation